All right, this is an introduction to statics here for the fall of 2018, so let's have a look. All right, so I'm David Kidd. You see my contact information up there. It's on the syllabus, which is available in the downloads section of Moodle. There's my office hours. You could reach me through email as well. The in-class section is Monday through Friday from 1 to 1:50 and IA 227. We often cover homework on Tuesday. That's pretty common in this class. I might schedule other things on Tuesday as well. Okay, so what we're going to do in here is we're going to analyze 2 and 3D force systems, moments, trusses, frames of machines, centroids, moment and product of inertia, shear and moment in beams, and friction. And we'd like you to be able to solve theoretical and most particularly applied problems in these areas and do it in a way that someone else could follow. All right, so we're going to cover 3-dimensional force and moment systems, resultants, moments, force and moment reactions, trusses, frames and machines, shape properties, which are centroids and moment of inertia, and shear and moment. So those are the things we're going to cover, and we would hope that you could, by the time you're done with this class, that you can analyze these different topics here and problems in these different topics. Okay, to be in this class, you should have had integral calculus and passed it with a C or better. Okay, the textbook primarily is the statics notes, which are available in the bookstore. They're a set of shrink-wrapped notes. I also think you should have a statics text. Any text would be fine, any edition. I like the Hibbler book. I think it's well written and can be read and followed pretty well. But any statics full textbook would be fine. It is important that you have the statics notes. We use them in the sessions, and the homework is also in the statics notes. Okay, the grading is as shown. I use 2 systems. One counts each of the tests, the 2 midterms and the final equally. The other weights the final more. So I run your grade using both systems. Then I have a little logic routine in my spreadsheet that compares the 2 grades and gives you a letter grade based on that. Now, this is more than the Moodle grading system can really do. So keep that in mind, that I post your scores in Moodle so you can see what the scores are that you've gotten. However, the grade shown in Moodle is not an accurate representation of what your grade is. The grade is found using these calculations here, which Moodle can't really do both of these at once and then compare them. Okay, so I use Moodle to post your grades, but it does not calculate your grade properly. All right, this class prepares people for a professional work environment, so we expect you to act in a professional way, to participate, to attend regularly, to treat other people respectfully, and to just maintain a good learning atmosphere in the class. Here's a course schedule. We'll just kind of work our way through these topics. They're in the packet as well. Okay, I don't have exact dates for the midterms. Midterm 1 will be late week 4 or early week 5. Midterm 2 will be late week 8 or early week 9. And I'll give you, though, at least a week's notice for the midterms. The final is the date shown below in black. It's Tuesday, December 4th from 2:30 to 4:30. Online students, if you have conflicts, let me know and we can work through those for the final exam. Okay, here's a list of things that are expected of employees. It's a good list to keep in mind when you're working as well, or when you're here in school as well. Let's see, we have some issues here with disability and emergency planning. So if you need any sort of accommodations, let me know and we'll take care of those. So no problem there. Anti-discrimination statement, you see a long list of different categories of characteristics of people that we do not tolerate discrimination based on these categories. I think basically that means just to treat people decently and with respect regardless of their background. I think that's the basic message there. Academic honesty. You're certainly welcome to work with other people to learn. I think that's a very good strategy to help you learn. But you do need to do your own work. So any cheating on homework or test will result in a 0 being assigned for that grade. Students who aid other students who cheat will also be held responsible. So aiding other students to cheat is cheating in and of itself. Okay, students have rights and responsibilities if you want, that you could explore on that website there. If you feel that your rights are being violated, you could contact Dr. Lynn Cox if that involves another student, or you can contact Scott Rowland if that involves a staff member here at LBCC. All right, now a lot of this class, as you're probably well aware, is run through the Moodle page, so why don't we have a quick look at that. All right, so here's the Moodle page. This is my version of it, so it might have more things in it than yours does, but this is the basic idea here. On the top, we can have some basic announcements. Okay, so that's usually what we have up top. The homework is listed here. Now, what these are links where online students can upload their assignments. So what you do is you complete your assignment, you scan it as a multi-page PDF. So you have to have all of the homework problems due for a particular assignment in one scan. And then once you have that one scan, you can upload it through these links. Okay. Okay, there are also downloads here. Notice the syllabus is right there. So you could look at the syllabus that we just went through. Here's a formula sheet, the required format for the homework. There's a grade calculator where you could run your grade following those formulas that I just showed you a minute ago. Here are the notes. This is scans from the note packet. So if you haven't got the note packet yet and you need some notes, they're available here up through the page shown. So you do eventually have to get the packet, but this will keep you going for a while here. There also should be some homework that you can upload as well, okay? So you can get to the notes that we use in class and the homework for the first couple weeks online, but after that you'll need to get the packet. So go ahead and proceed with getting the packet, okay? All right, so then we have all of these things that you can download, I guess. So we've got some notes here. We also have some homework downloads here as well. And then some test review materials, okay? And then I'll post the links to the recordings of the sessions here, so you can click on those, and that'll take you to YouTube so you can watch the sessions. Okay, so that's basically the Moodle page. Pretty straightforward, really. All right, there's the required homework format. So I would like your work to be neat and organized, and importantly legible. That's a very important skill. Be sure that I can follow it, or anyone else could follow the work that you're doing. Use a straight edge, use arrows to show the directions of forces and moments. Put all the answers to one problem in a box. Put one problem per page unless the problems are short. Make your own sketches. Get used to making quick line sketches. That's a good skill to have. Show units in your answers. So here's an example. We've got name, date, problem number, page numbers, a paraphrase of the problem statement. You don't need to write the thing all out, just paraphrased is fine. A little bit of a line sketch showing the situation. Here's the work through. Notice the equations are labeled so someone can follow it. And then all of the answers to the problems are in one box. So that's what the homework should look like. There's the formula sheet that's available for you to download. Okay, let's look at what it will take to succeed in this class. We want you all to succeed, so let's have a look at what some of those things might be. Okay, here's an old article from the Barometer, which is the paper at OSU. They asked a student what he learned at OSU. this year, and his response was showing up for class is pretty important. So I think that is very important to show up and engage in the class. Okay, here's another article. I think this is 1999 from a Mars rover. The design team who worked on this used the metric system, I believe, whereas the operational team thought they were in English units. The result of that was they crashed the Mars rover into Mars. So that was obviously a big mistake and caused some real problems there. It scratched the whole mission, I think. So here's the importance of setting up your work properly, including units and doing those sorts of things. There's a real world example of that. Okay, here's a movie that my daughter used to watch quite a bit. Here's the romantic leads here. At one point, the young lady here says to the young man, "I can explain it to you, but I can't understand it for you." Okay? She's a little exasperated with him when she says that. Now, my job is to explain it. Your job is to understand it, okay? So keep that in mind. I explain it, but to understand it, you have to do the homework. You have to process the information. You have to engage. So that's one tip there in succeeding at this class. Get engaged and be sure that you're doing the things you need to do to understand the material. All right? So I assume everybody here wants to become a successful engineer, so now it's time to start acting like a successful engineer. Okay? And as far as school goes, that means showing up for class. It means actively engaging in your courses. It means doing your homework. Importantly, it means if there's something you don't know, ask. Okay? Essentially, you're paying me to explain this material to you. If there's something you don't understand, that's fine. You know, ask me, ask some tutors, ask some friends, but engage and try and find answers to the questions you might have. We have tutoring help here on campus that you could use as well, okay? So that's just some advice to be successful in the class. Okay, I have a video and the link is posted in Moodle on why statics is important. So once you have a look at that, it's just a little 2 or 3 minute video that will get you a look at some real world statics. All right, now let's have a look at some other information here. This is out of the packet. So this information is in the statics packet. If you haven't already gotten it from the bookstore, I would order it. And if you don't have it yet, I would just download that material from Moodle that I showed you, and that will get you these pages in the packet. One of the main ideas here with the packet is that if you have that, a lot of the notes are already written out in it, so you don't have to copy everything down. They're already there. Okay, now not everything's there, of course, but there's a lot of information there. So that's one reason why I want you to have this. Okay, now the packet is laid out in kind of a funny system. The beginning is the homework problems. That's about pages 1 through 32 or 34 or something like that. And then that's the homework. After that, I start numbering on page 110 for the notes. So the homework is the first so many pages. You have to go about 1/3 of the way through the book to get to the in-class notes. The in-class notes start on page 110 and are numbered by 10. So 110, 120, 130, 140. That way, if I need to put some new notes in, I don't have to use, I can just put something between 120 and 130 and call it 125. It just makes it easier for me to number. So the numbering's a little funny, but it's sequential, okay? So this is right out of the packet, what I'm going to show you here. All right, just a few definitions here. This is right out of the packet. Engineering is focused on applied practical problem solving, okay? What we're going to do in here is we're going to learn about mechanics, engineering mechanics, and we're going to have you learn and practice analytical problem solving and have you present your work in an organized way, okay? Now, significant figures, we use 3 significant figures, okay? Now, often I'll carry numbers in my calculator. If I have to take them out of my calculator, I'll use 4 significant figures as I'm calculating. But when I get to the answer, you can just report 3. That's fine, okay? that's plenty good for structural engineering, which is kind of what people do with the material we're learning here. Now keep in mind, in a math class, that's a very good answer there. You know, that's an exact answer, 4 pi. That is not a good answer in our class, though, because a surveyor can't lay out a line 4 pi feet long. Okay? This isn't a very good answer either, because it's got way too many significant figures. If you ask a surveyor to lay out a line that long, that surveyor might spend an awful long time working on that and give you a very big bill to do it, because this has got so many significant figures in it. So for our class, we can use 3 significant figures for our answers. So an engineering answer in this class that would represent 4 pi would be 12.6. Now, if you use 4 significant figures, 12.57 or something, that's fine. I'm not going to get too worried about that, but I do not want to see answers like this. Okay, that's too much. I don't want to see answers like that either. I don't want to see answers with only 2 significant figures, because there's too much rounding error that can be introduced there. So 3 or 4 is plenty good. Okay, mechanics is the analysis of the effects of forces acting on objects. Objects at rest generally are statics. When things start to move, we use dynamics, which is the next class that follows this. It's ENGR 212. Okay, some basic definitions. Mass is the amount of atomic material, which is also it's a resistance to a change in velocity. In the English system, it's measured in kilograms. Excuse me, in the metric system, it's measured in kilograms. In the English system, it's measured in slugs. Kind of an odd unit, but in the English system, which we use in this country, it's measured in slugs, okay? So kilogram in the metric system, slugs in the English system. I hope I said that right, but there you go, okay? So a slug is kind of an unusual unit, but it is the mass unit in the English system. A force is a push or a pull. Weight is a force caused by gravity. A force is measured in newtons in the metric system, pounds in the English system. Acceleration is a change in velocity measured in meters per second, which would be meters per second squared, or foot per second, which would be a foot per second squared. Now, on the Earth, we have roughly a constant acceleration caused by gravity. So if we drop an object, it accelerates at a given acceleration regardless of its mass, okay? So on Earth, the acceleration due to gravity in the metric system is 9.81 meters per second squared. In the English system, it's 32.2 feet per second squared, okay? So we relate these things together with this equation right there, F equals ma. The greater the force we apply to an object, the more for a given mass it will accelerate. So if the object is not adequately supported and it starts to move when we apply the force, the more force we apply, the greater the acceleration. There's a corollary to that, that weight, W, is mass times the acceleration due to gravity. Those 2 accelerations there. Okay, so when we work with those units, what we end up with here in the metric system, then the force is a newton. 1 newton is 1 kilogram meter per second squared. In the English system, 1 pound is 1 slug foot per second squared. Okay, so let's work through an example. This one isn't in your packet, so you might have to write this one up. Let's say we've got a space vehicle and it has a mass of 135.2 slugs. Let's find its weight in pounds, its weight in newtons, its mass in kilograms, its mass on the moon, and its weight on the moon. Okay, here are the conversions that we'll use. So we've got a pound is 4.448 newtons, and also that the moon's gravity is 5.325 foot per second squared. Okay. So let's see if we can go ahead and do this. Now I'll move through this pretty quickly, so keep in mind if you do need to copy things down, you can just pause the recording and do that, okay? But I'll keep this recording moving pretty fast. All right, so we're going to work with F equals ma. The corollary to that is weight, W, is mg. G is the gravitational acceleration. So what we've got there is the mass in the English system, 135.2 slugs. If we multiply that by the acceleration due to gravity, we'll get the weight on Earth. 4353 pounds. We can then convert that to the metric system and get 19,364 newtons. Okay, so there's the weight on the Earth in pounds and newtons. All right, now if we want to find the mass on Earth, we can take the weight in the metric system and divide it by g in the metric system on Earth. So that's 19,364 newtons divided by 9.81 meters per second squared. That will get you 1974 newtons second squared per meter, which is a kilogram. So that's 1974 kilograms. Okay. Now we calculated that for using Earth's gravity and the weight on the Earth. However, mass would not change. You would have the same mass on the moon as you would on the Earth, because the amount of atomic material doesn't change regardless of where the object is. So the mass is the same regardless of where you are. So the mass on the moon is the same as it was on Earth. So 1974 kilograms and 135.2 slugs. However, the weight on the moon will change. It'll be different than the weight on the Earth because the gravity on the moon is not as strong as it is on the Earth. So the weight on the moon will be the mass, the 135.2 slugs, times the gravitational acceleration on the moon, which is different than it is on the Earth. It's 5.325 foot per second squared. So the object would be quite a bit lighter on the moon. 719.9 pounds. We can convert that into newtons and get 3202 newtons. Okay. So that's just a little bit of an example here to show some of these relationships between force, mass, and acceleration. The corollary to that is weight, mass, and the acceleration due to gravity. Okay. Now on Wednesday, I'd like you to do number 112 from the packet. And again, that's available to download in Moodle if you don't have the packet yet. So if you're an online student, you can do that. You can scan it as a PDF and then upload it in the link I showed you in Moodle. Okay. Now, if this were a homework problem and I was going to turn it in, I would put all the answers to these questions in a box and I would round them out to 3 significant figures. So notice I kept all the significant figures, or quite a few of them anyway, as I work through the problem. Then when I'm done, I round them out. Okay. Okay, so there you go. All right.